Hello everyone, hope you are doing well. I'm Sir Saeed and today we are going to solve some past paper question, and the past paper is Feb-March 2016 paper 1-2. This is A levels paper and we will solve some questions. So let's start. In question number 1, you have to tell which row is correct. It's nano 10 is per minus 9, micro 10 is per minus 6, and pico is 10 is per minus 12. So straight away option C is correct. But in this question, two forces are acting from a frictionless pulley, and another force F is acting at this point. This is the crane arm. So the forces are 10 kilonewton and you have to find this force. So first of all, we have to divide these forces into the components. Say if we draw it like this one and this one, then we draw these forces into the components. Initially, one of the component is here and the other component is in this way. For this, one of the component is here and the other is over there. Just let me change the color. Okay, this is angle. The component which is close to the angle is cos, the other is sine. So this component is 10 cos of 30, the other one is 10 cos of 30, while these two components are 10 sine of 30, which is not required in fact. So we may write it as this is F, which is required, and the two components are in this way. So if add these two components, we can get the answer. That's why F is equal to 10 cos of 30 plus 10 cos of 30. The answer will be 17 kilonewton. Option D is correct. Now on the next slide, you have to write question number 3. Specific heat capacity expressed in SI base units. So this word base is important. So it is written as joule per kg Kelvin. You may write joule in Newton meters per kg Kelvin. In this, only the Newton is the derived unit, all other are base. So instead of Newton, we may write it as Newton is equal to kg meter per second square. From F is equal to ma, you know it. So Newton is kg meter per second square. This meter is here and kg and Kelvin are going to divide. So this is kg meter square. Kg is cancelled with the kg, so it is written at meter square s power minus 2 and k inverse. So option C is correct. This is the correct option. Done with 3. Now moving towards 4. These two values are going to divide with each other, and you know that the fractional uncertainty is in fact the absolute uncertainty divided by the actual value. So if this is x over y square is given, then the power of x is 1, so 1 is multiplied with the fractional uncertainty of x, that is the small x is like this one, plus the power is 2, the 2, and then the multiplied with the fractional uncertainty of y, and it is small y. So the answer is x plus 2y. Option C is correct. Clear? Just to have a little more explanation, if we have this question, then we have to apply the power factor. Power factor means the power of the value x is multiplied with the percentage uncertainty of x, and 2 is multiplied with the percentage uncertainty of y. Means 1 multiply with the percentage uncertainty of x. Percentage uncertainty means the fractional uncertainty in 200 plus 2 the power of this y is multiplied with the percentage uncertainty of y, that is fractional into 100. And you know that 100 is not required because you have to write the answer in terms of fractional uncertainty, so ignore these two hundreds and the remaining answer is x plus 2y. Similar. Moving towards question number 5. In question number 5 it is simple. Here the galvanometer is attached between these two wires. The galvanometer reads 0. The galvanometer is used to detect the current. If it reads 0 means no current is flowing through it. There is no current which is flowing from Q to Y or Y to Q. And when there is no current means there is no difference of potential between these two. There is no potential difference. Hence we may write it as the potential difference between the Q and Y is 0. It means the voltage is 0, so I is 0. So I is 0. And if I is 0 means there is no current to be detected by the galvanometer. Anyhow, question number 3. To solve this question, the equation is given as this is actually third equation of motion. Which condition must be satisfied? This must is written in a bold letter. So in all this equation, you know that the direction of A is constant and the direction of A is same as the direction of S. The direction of A is constant and the direction of A is same as the direction of U. The magnitude of A is constant and the direction of A is constant. And you know that this equation is valid when A is uniform acceleration. If acceleration is uniform means not the magnitude nor the direction of the acceleration is going to change. So option C is correct because the magnitude of A is constant and the direction of A is constant. It means A is completely uniform. That's why this equation is valid. So this condition must be satisfied. Some more conditions may be satisfied in this about the direction of velocities, but this condition is the must one. So question number 7. In question number 7, actually this graph is a little confusing for the students because they may think that this is the velocity time graph. No, it is not. On x-axis this is not time. It is actually the distance. So it is the velocity distance graph. But a car is traveling in the constant velocity, brakes are then applied, causing the uniform deceleration. Yes, it has the uniform deceleration. So which graph shows the variation with distance s? You know that like v is equal to u plus at? No, 2as is equal to v square minus u square, because in first two equations we have time involved. No time is given here, so we have to write this equation. And here we may write it as that v square is equal to u plus 2as it is square, and you may write it as v is equal to under root u square plus 2as. All these factors are constant, the initial velocity to acceleration, so we may write it as s power 1 by 2 or under root. It means when we are going to draw the graph, initially the velocity is constant. We know that the velocity is constant, the velocity is constant, constant. But these two are completely wrong initially, because this graph shows that there is a change in the velocity from maximum to minimum value. here, but there is no distance traveled. It is not possible. And in this graph there is abrupt variation at this point, so this is not valid as well. There's a confusion between A and C. But look at C. This graph is initially okay. We may solve it like this one. Look at here, we have a vertical straight line. This vertical straight line means there is a change in the velocity, but there is no change in the distance. Not possible. This is the correct answer, because initially the velocity is constant up to this point, then it is going to decrease, and the distance is occupied as well. So we can say that there's a decrease in the velocity, means we have the deceleration. That's why option A is the correct one. Or in other words, if you draw the graph by using this velocity and s power 1 by 2, you may have this type of a graph as well. In question number 8, this question is the question of the projectile, and air resistance is ignored, so it's completely projectile. In projectile, you know that the ball lands with the same velocity at which it throws, means if the velocity is in this way, and when it comes back the velocity is in this way, these velocities are not equal. Even their magnitudes are equal, the direction is opposite, the direction is different, so we can say that the velocities are not same. Option A is wrong. The horizontal component of the acceleration is constant. Oh, the horizontal component of the acceleration means ax is 0. The horizontal component of the acceleration is constant, means the horizontal acceleration is 0 and it remains 0, means at this point or this point, somewhere over here, during all this horizontal motion the acceleration is 0. 0 means there is no variation in the 0, so it is constant. That's why option B is correct. Clear? And the C is wrong, because the horizontal and vertical components of the acceleration are both 0. No, it's not. The vertical component of the acceleration is not 0, it's g, which is 9.81 everywhere. So this is wrong. The horizontal and vertical component of the velocity are both 0 at the highest point. At highest point, the vertical component is 0, but we have the horizontal component of the velocity, so it's wrong as well. That's why option B is correct. Okay. Force, very simple. You know that the definition of the force is actually the rate of change of momentum. So we can say that when the force acts on the body, the force is the product of, no, it is not. It is the relation, not the definition. When the force acts on the body, the force is rate of change of momentum. So straight away option B is the correct one. Moving towards question number 10. Question number 10 is related with the vectors, and to get some more understanding of the vectors you can see the other video, the vector addition. Anyhow, here we have, say, this is the vector, momentum vector, this is another momentum vector. By head to tail rule, we have to join the head of first vector with the tail of the second. Here the tails are attached, so we move this vector over here. So this vector is mu by 3. This vector is over there, like from using highlighter. This vector mu3 and this vector mu3 are equal vectors. So we just draw this vector here just to fulfill that, the head to tail rule, the head of first vector attached with the tail of the second vector. So the vector which joins the tail of the first vector with the head of the last vector is called resultant. So according to the conservation, this resultant vector having the same momentum which we have over there, that is the initial momentum, and the momentum over here is mu, because the momentum of this bigger mass is 0, it is at rest. So this vector is mu. Now about the angle, this alpha and this angle are same because they are opposite angles, that's why they are same. Or in other words, you can say that the angle between this component and the horizontal line is alpha. So over there, this horizontal line and this component angle is alpha. So look at here, this is the correct answer. This is the correct answer because this is the resultant vector mu, and by head to tail rule exactly we are going to follow this one. Not correct because there is no resultant, and I told you earlier that how you come to know about the resultant. For the resultant vector, the head is attached with the head and the tail is attached with the tail, so this B is correct. Moving towards next question. Here we have the velocity time graph here, but in this question, uh, using the same scale represents the object falling in air. It's falling in air. Falling in air means the terminal velocity. Terminal velocity is actually the constant velocity. So this is wrong, this is wrong, but we have the confusion between B and C. B is wrong as well because in the beginning there is some velocity, but the time is still zero. It's not possible. So this is actually the graph, which is the graph of the terminal velocity. Look at here, the velocity is increasing with the decreasing gradient, and at the last it will become constant. So this is the correct answer. And now look at this thing. This is the beam, and when it is said that the beam is uniform, it means the weight of the beam is exactly acting at the center. Look at here, this is the center where the weight of the beam is acting, and the weight is given, it's 50 Newton. So if this is the pivot and this distance is definitely 0.5, this is the moment arm. So to get this W, we have to apply the principle of moments, means the clockwise moments must be equal to the anti-clockwise. This force 50 Newton will try to rotate the beam in this way, that is the clockwise. Always the force of the torque or the moments will move the body towards the pivot, and for this W it will try to move in this way. So we may write it as 50 Newton force multiplied with the moment arm, this is 0.5, is equal to the force W which is required multiplied with the moment arm 1.0. So the W is 25 Newton. That's why option A is correct. We have done these two questions. Moving toward question number 13. Okay, question number 13. The question number 13 is related with the couple. In the couple, you know that two equal and opposite forces uh, are acting on one body at two different points to produce the rotational effects. Means this force and this force is always equal, and the distance between these two forces is 2r, and this is the perpendicular distance between the forces, perpendicular distance. So to get the couple, we generally write it as 2rf. 2r is actually y here, so this is yf. That's why option B is correct. This x is not the perpendicular distance between the forces, y is the perpendicular distance, and the angle 90 is shown in the diagram as well. So you have to multiply one of the force with this distance, which is written as 2r here. So option B is correct. In question number 14, a giant squid of length 20 meter in vertical seawater, means we have this 20 meter of length and there is seawater here. This is 20 meter in fact. and this distance is given, that is 8. Yes, it is 8 meter. So if you have to find the difference in pressure, then delta P is required. Delta P. Delta P is mg, sorry, delta P is rho g delta H. So rho is 1050, density it's 9.81, and the difference of pressure is in between these 2 points, so the delta H is straight away 20. Hence, by multiplying all these we can get the answer, and it is option B. And you may solve it like this one. If you write it as delta P is rho g h2 minus rho g h1, so rho g is common, that is h2 minus h1, and look at the h, this is h2 and this is h1. By subtracting h2 and h1, again this 20 meter is over there, so you can have the same answer. This was question number 14. Now moving towards question number 15. In question number 15, on this aeroplane, two forces are acting. One is down, one is up, and these forces are balanced. It means nothing to do with the vertical motion. And in the horizontal motion, the 200 kilonewton of air resistance, and the engine's thrust is 500 kilonewton. So we can find the force by subtracting these two forces. You have to write the rate at which the kinetic energy increases. Rate of kinetic energy means kinetic energy per unit time. So power is required. Energy over time, the power is required. So you may get the power by relation FV. The force is 300 kilo 10 raised by 3, and the velocity is 40. By multiplying these two you can get the answer, and it is option C. Okay, in question number 16, this question is related with the approximate values. So if you have to write the kinetic energy, the relation is half mv square. Initially, the mass of man is required. You have to approximate this value, maybe 70 kg or 80 kg. Okay, you write it as 70. And the velocity is v by d. So if we can say that the race is 100 meters, and the runner may cover it in 10 seconds or 15 seconds, or maybe in 20 seconds, so the velocity is 10 meter per second. We just suppose that is the athlete running very fast. Anyhow, if we write it is this way, the answer is in thousands. If we change these two values, means the mass and velocity, if we have to any sensible value of mass and velocity, the answer will be in thousands, not in 10,000s and not in hundreds. So option C is the correct one. Moving towards question number 17, sorry. Look at this question. The water pumping system used 2 kilowatt of electrical power while rising the water. To use it, so it is the input one. The pumping system lift 16 kg water per second. So mass over time is given here. This mass over time is given, and up to the height of 7. So the potential energy is involved here. Efficiency is in this way. you have to write the useful output over input, and input is 2 kilo, means 2 into 10 is per 3 watt. And to write the power at the top, the power is mgh over t, energy over time, and this mgh over t is actually 16 divided by 1, so 9.81 into 7 is given. So it's 16 into 9.81 into 7. By solving this, you can come to know that the answer is D, 55 Newton. Moving towards question number 18. In this question, this is a force extension graph, and you know that the area under this graph is equal to the energy. Initially, the graph is going to start from the origin. It means there is a force which is acting on the body is going to stretch, and the graph comes at this point. So if we get this whole area, this area will give us the energy which is given to the body for the stretching, for the extension, or in other words, this energy is equal to the work which is being done on the body for this extension. So straight away, this is the work done in stretching the wire. This is the correct answer. If you have any other doubt, like in option A, the change in, there is nothing to do with the gravitational potential energy, height is not involved here. The energy that will be released from the wire, no energy is coming out from the wire while the load is removed. When the load is removed, that is the line which is coming towards extension, not going away from the extension or x-axis. So it is wrong. The energy transferred into heat, no, this is not the stored energy, it is the given energy. That's why option D is correct. Okay, while solving this last question is question number 19, and this question is related with the deformation. We have these two wires attached. First of all, the Young modulus of the steel wire is twice. Means for this wire, the Young modulus is 2E, and for this wire, the Young modulus is E. The length of both wires are 50. It is 50 cm. It is 50 cm. 50 cm. The force is same, which is going to stretch these wires. The diameter of the first wire is 2 millimeter, and the diameter of this steel wire is 1 millimeter. Now the extension in the steel wire is, you can say, E, and the extension in the copper wire is E dash. For it's E and it's E dash. The ratio is required. Just to recall a relation, you know that the modulus of elasticity is F over A E by L, and this area is always pi r square, and for the cylindrical wires we may write it as pi d square by 4. So this E can be written as F L over pi d square by 4. So this is the formula which is always required. So for this copper wire, say the modulus is E, this is 4, it is constant, this F is constant, the length is, you can say, 50, and there is extension here. This is called extension E dash for the copper, and this is pi 2 square E dash. Clear? So to write the same relation for the steel wire, the modulus is 2E, this is 2E, this is 4F, the length is 50, pi is constant, diameter is 1 square, and the extension is now called E in this case. Look at here, I'm not going to change the units. I'm not going to convert the units because the units are same. When we will compare these relations, the units will be cancelled out. We may compare them like for F50 is same on both sides. E can be substitute over there or by any mean. I'm just going to put this E over here. And then at the last we will cancel the common factors. For example, this 2 is here and this E is 4F. This is 50 by pi 2 square E dash is equal to 4F50 by pi 1 square E. So during this comparison you can see that 4F50 is cancelled on both sides, this pi is cancelled, so we are left with 2 divided by 4 E dash is equal to 1 over E. 4 is actually the square of this 2. So it is cancelled and we are going to cross multiply this because E by E dash is required, that is E by E dash is equal to 2 by 1. So option B is correct. One hint: when you are going to solve the questions of the deformation, just try to solve the problems by comparing the relations. And that's all for now, and thank you very much. Good luck. See you.